Good morning. Good morning. It's a good morning. I'm glad you're here. Today we are going to be looking at one of the things that keeps coming up in proofs often, and it's the same similar idea. Bisector, right? Something that cuts something into two congruent pieces, or midpoint, and we see both of those showing up when we've been writing some proofs. So let's take a moment to think about midpoints, uh, or it bisects also midpoints in the context of the XY coordinate plane. So I have here a beautiful triangle, right? Triangle ABC in sitting here in this is GeoGebra, not Desmos. And what I want to do is I want to think about, what are the midpoints of these sides. And certainly as I look at it visually, I can see, well, oh, I just messed that one up. Visually, I can see where that midpoint is, right? I can see this spot right in here where it looks like, yeah, that's clearly the middle of those two. And I could even use the Pythagorean theorem twice to prove to myself that, yeah, that is the middle point. But let's take a look at this a little bit more and think about different techniques we could have for locating and identifying the midpoint of a point. So to do that, let's start by identifying the coordinates of point A and B. Point A lives right here at 2, comma 2, and point B lives at 4, comma 8, 4, comma 8. And I can see that if I was going to travel from point A to B, right, I have this rise pattern of, what is it, going from 2 to 8. So this rise pattern, y starts at the number 2, right? You can see right here, y starts at the number 2 and y ends up at 8. And if I travel from 2 to 8, the length of that line segment from 2 to 8 is exactly 6 units long, right? 8 minus 2 is 6. And then if I travel along the x value, I'm going from 2 up to 4. As I travel along x, right, that from 2 to 4 is a change of 2 units. So I have here now, if you think about it, I have this right triangle. And if I want to get to the midpoint, I could say, look, I'm going to travel starting from point A, but I'm not going to go the whole distance, right? What I'm going to do is I'm going to say, well, look, the distance I have to travel along the y-axis is 6 if I wanted to go the whole way. Let's just travel half of that distance. Let's just go half that distance. And if I do that, I'm going up 3 units, right? I'm going up 3 units, up 1, 2, 3 units. And then instead of going over the full 2, I'm just going to go over 1 unit. And you can see this lands me right here at this midpoint, and the coordinates of this midpoint are 3, comma 5. 3, comma 5. So that's kind of one way to think about it. I can think about, all right, let's figure out how far my total y travel is, my total x travel, and then just take half of that travel, and then add that to one of my starting points. So that's the tricky thing. I know, oh no, this is, yeah, x is 3, y is 5. So if I think about this, this y value became 5. Why? Because I took 2 and I added to it half of my travel, right? My travel was half of 6. And my x value was 2, and I added to that 2 half of my travel, right? And my travel is right here. Half of that travel is 1. So my coordinate became 3, comma 5. So that's one way we can get at what's the midpoint of a point. And some people prefer that. Certainly, I think in some contexts, it's a good way to think about it, just, just in terms of like what exactly is happening, and fabulous. But let's consider a different approach, and it has kind of to do the idea with this arithmetic mean. Like what's the average? What is the mean, right? What's the distance between two numbers? So if I think about this, I could say, look, I've got the number 3, and then I've got the number 15. Somewhere in between 3 and 15, there's the number that's in between those two. Okay, How do I find out what's in between? Well, I could do it a couple ways. I could look at the number line, and I could, just like we did with the diagram over on the triangle, I could count. So I could say, okay, I'm going to start here at 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Well, I want to only go to 15. And here's the number 15. Oh, geez. How many steps did I take? I'll put a dot at each step. I took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I took 12 steps. Okay, let's not take 12 steps. Let's just take 6 steps. So I could go from the 3, I could say there's 1 step, 2 steps, 3 steps, 4 steps, 5 steps, 6 steps. That puts me right here. What number is that? 3, 4, 5, 6, 7, 8, and 9. So it looks like the 9 is right in between those two. Right? 9 is the number in the middle of 3 and 5. It is the midpoint. Okay, but that's just doing what we did on the other diagram, right? That's figuring out how many steps you have to take and then taking half of the steps. Is there an easier way besides counting like that? And I could mathematize that too, but I think this is maybe a more straightforward approach. If we think about it, if I take two numbers and add them, and then I divide by 2, I'm finding the arithmetic average. I'm finding the mean of those two numbers. 3 plus 15 is the number 18, and 18 divided by 2, right, is the number 9. So one way I could get at the middle of two numbers is to just find their average. So let's go look at what consequence that has for our triangle. Let's come back over here. So you can see I've used red for the x-axis and green for the y-axis. So if I go ahead and take my x values, I've got 4 and I have 2. I add those together, and then I'm going to take half of that. Well, 4 plus 2 is 6, and 6 divided by 2 is 3. So I could figure out where my x coordinate's going to go by taking the average of my two x coordinates. So I just added the 4 and I added the 2 and then divided by 2, and I got 3. So 3 is my x coordinate at my midpoint. And I could do something similar with for y then too, right? If the y's are at 2 and 8, well, 2, or I can say 8 plus 2, it doesn't matter the order, 8 plus 2, I'm just taking the two y values, 8 plus 2 over 2, 8 and 2 is 10, and half of 10 is 5. So my y value ends up being at 5. So my midpoint is where y is 5 and x is the number 3. Now, if I was going to completely abstract that and think about it not in terms of a particular point, but just an abstract point, we'll just think, and maybe this would be noteworthy, maybe it wouldn't be. Let's say that I have two different points on the Cartesian coordinate plane. I'll call this point 1, and I'll call this point 2. In point 1, I have the coordinates x1 and not an x2, x1 and y2. Over here at point 2, I have coordinates y1 and why did I do that? No, I always have an x value. I have point y. I did it twice. I did it. Am I going to do it a third time? I hope not. I have point x2 and y2. There we go. That's what I meant to say. Although, did I put a y2 down there? That's ridiculous. Okay, so just so we're all clear, point 1 has an x and a y, and I'm labeling them x1 and y1. Point 2 has an x and a y, and I'm labeling them x2 and y2. Now, if I wanted to find the coordinates of the middle point, right, the coordinates of the midpoint would be the sum of the two x's. So I'm just going to add x1 and x2, and I'm going to divide that by 2. And the sum of the y's, y1 plus y2, and then I'll divide that by 2. So this, right, produces the x at the middle and the y value at the middle, right? Just finding the average of those endpoints. So there's one other idea that I want to investigate before we stop today, and it has to do with the lengths of the sides that result when we end up having a triangle and its midpoints. So we're back here at our triangle, and to our triangle, I want to add something to it. I want to add um, I want to add the midpoint to at least two of the sides. So uh, there's a great way to do that by construction, but there's also a very easy way to do that in just by selecting a tool. You can see that under the construct menu, there's a lot of steps. There's a few steps involved with finding this, but this is like, hey, construct midpoint or center. So basically, it tells me select 2 points, a segment, a circle, or conic. So all I have to do is just pick a segment, and it will construct the midpoint. And I don't have to click near the middle, right? If I want the midpoint of this, I could just click somewhere on that line, and there it is. Point E is the midpoint. And when I take the midpoint of two sides of a triangle and I join those, we get something that we're going to call a mid-segment. So line DE is a mid-segment of this triangle. And there's probably a lot of things I could do to look at and consider properties of this. But one of the things I want to do is just consider. I can almost visualize that. Look at this. This is very interesting. If I take point B and I drag it, let me get this out of the way. If I take point B and I drag it all the way to point C, notice that DE, right? DE ends up becoming half the length of AC. In fact, when B makes it all the way to C, D becomes the midpoint. Oh, it does it really? Yeah, let me if I move C up a little bit more here and do that again, watch where D goes. Mm-hmm. And if I come over here, watch where E goes. Mm-hmm. Which I could observe this in a couple different ways, right? But when I watch something and I'm just kind of, away, away, sitting, maybe I'm sitting somewhere along the Sacramento River, kind of quietly by myself and thinking about things, I might consider some things outside of the voices that we hear, and I might say to myself, huh, I think there's something that's true here. And I don't have any evidence of that yet, but just from this observation, I'm starting to think that there is a relationship between DE and AC. And to investigate that relationship that I think might exist, I'm going to make a couple measurements on here. So on the measure menu, I just want to know the length of two segments. So I want to figure out how long is this segment DE, and I want to calculate how long is the segment AC. And at first glance, it doesn't seem especially compelling because I don't, clearly recognize these. Well, and then I look at it a bit more, and I'm like, no, I actually think I do see this, right? It appears, it appears that there's a relationship here that the length of this mid segment is one. Oh, that's a nice number. It appears that it's one half of the length of the side that it is. Ooh, I think it's parallel to it, isn't it? Right? So if I was to go, yeah, I think they're parallel because this has a slope of up 1 over 1, 2, 3. No, it doesn't have a slope of up 1. It didn't go up 1. Let me bring this up here so I can make this slope. That didn't help me, did it? That did not help me at all. Oh, that gave me a slope of 1 something. So DE has a slope of up 1 over 1, 2, 3, 4 and a half. This one has a slope of up 2 and 4.5. If I double 4.5, I should get 9. So this should have a run of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my rise is 2, the run is 9, the rise is 1, the run is 4.5. So these lines appear to be parallel to each other because they have the same slope. Now I would not at this point, just from a few observations, say, well, therefore it's always the same. But certainly this is worthy of consideration. And I might think about how can I make an argument how can I make an argument that the length of this thing that I'm calling a mid segment, right, is always going to be half as long as the side that it's parallel to? Or I could say this another way. There's a side of a triangle, and the mid segment that's parallel to that is half as long as that side. So I either double the mid segment to get the side, or I take half of this side to get the length of the mid segment. But we're going to leave it there. So, in summary, today, the two things I want you to walk away with is we should be able to find the midpoint of a segment that's on the Cartesian coordinate planes by looking at its endpoints. And one of the ways we illustrated was this idea of finding the average of the x coordinates and the average of the y coordinates. The other thing is this open question. Well, this is a definition, right? A midsegment is a line that connects the midpoints of two sides of a triangle. So if you start with a triangle, find the midpoints of two sides and connect that, you now have a midsegment. And the open question is, if you have the midsegment of a triangle, right, is, if the length of that mid segment is x, is the length of the side that's parallel to it, right? This would be the one that's parallel to it. Is it 2x? Is that relationship hold? And what would an argument look like that would be sufficient to convince us that that's true? What would that look like to convince not only yourself from experience, but to be able to communicate it with others in a convincing way? All right, that's it for today. I hope you have a great day. I look forward to seeing you tomorrow. I don't know if it's the same time. I don't know when you watch this. I'll talk to you later. This is Mr. Roberts. Have a great day.